Hello everyone, I'm Flora and this is my System Software and Compiler Design Lab Expert number 10. So today what we're doing is I'll be working on intermediate code generation. So basically what it is a compilation process. It is divided into a number of subtasks which can be called as intermediate code generation or phases, and all of this form a phase of a compiler. So the compiler creates an intermediate form which is helped in code optimization to make clear-cut separation between machine independent phases. So basically intermediate code generations are of various forms. One of them is tree address code, the other one could be a parse tree. So in tree address code, what we do is we input an equation and convert it into a tree address code which would look like A equal to B operation C, where A, B, C can be names, constants, temporary names, and operation. OP stands for an operator, which could be addition, subtraction, multiplication, division, any of that. And postfix notation that we use, that we pass from a parse tree, is another form of an intermediate code. Now, what I've done in my experiment is I have saved details of the operators. Suppose it's a multiplication, a division, a plus or a minus operator, and I have given precedence for it. So according to my program, multiplication and division will have same precedence and plus and minus will have same precedence, which would be lower than multiplication and division. So when an expression is encountered, according to the precedence, the operations will be evaluated. So next what I've done is I've asked the user to input the expression, and I have saved all the expression in an array. I have assigned the entire array to be false. I will convert it into true when I solve that particular expression. Suppose if I have A plus B, I have the expression, I have inserted all A plus B into an array and I have assigned it false. So when I evaluate that, I will turn the false into true so that I could keep a track of all the expressions that is evaluated and is not evaluated. Then what I've done next is according to the precedence order, whether it's multiplication, division, plus or subtraction, I have sorted that according to the precedence order. So once I have sorted, I would be able to evaluate it. So my next step that I've done is I have evaluated the operation. Suppose if it is 5 plus 3, so I have evaluated the operation. I have inputted the integer value if it's a number. I have evaluated the operation and that is stored in another variable. So this is what I've done in intermediate code generation. So when we run this experiment, it will ask us to write an expression. Suppose if we write A plus B plus C minus D. Now in this case, in all the operators, A, plus and minus have the same precedence. So this would be solved in a left to right associative. So first we will evaluate A plus B. We'll store it in a variable called T1. Then we will evaluate this T1 expression with the next variable, that is C, and we will store it in a variable called T2, and then the final expression will subtract it and store it in another variable called T3. So these variables will keep on increasing as number of expression varies. Another example that could be expressed is using a plus operator. We'll be able to solve. So first, since multiplication and division have the same precedence, any one is used. So since we are going from left to right associative, so we have solved the multiplication expression first, then we have used that variable and solved the division, and then the plus and then the minus operator. So this is all for my intermediate code generations. Thank you.